Mr. Arslan Ahmed.
Yeah, I'm here. Hi. Can you hear me?
اوكي يا شباب دلوقتي في حد عنده شاير الاختيارات طبعا بعدين ممكن اختار المشكلة فعلا مش بايدي I tried ان انا اعمل جونيور شير سكرين الناس مش هيلحق
في طريقة ان انا اوصل لمعلومات دلوقتي لو في طريقة ان انا ممكن اعمل بيها دي.
هو أظن معرفش هل في وسيلة تانية بس أظن هو دي واحدة.
خلاص يعني متقدرش بس ثواني اشوف مين هيبقى لايف على بقينا لايف.
Okay. Okay. You can share your slides, Mr. Arslan.
Sure.
Okay, hello guys. Hello everyone and welcome. Welcome to a new GDSC talk. Today we have a very special guest. We have Mr. Arslan Ahmed. Welcome, Mr. Arslan.
Hi, thank you for joining. Thank you for inviting me. I'm
We're
really
glad
glad.
to have you today.
Yeah, same here.
Thank you. Okay, I think we shall start. Okay.
Can you share? Can you see my screen?
Yeah,
Sure.
everything is
All right.
good.
Okay. So, all right. Yeah. So let's start. So my name is Arslan Ahmed. I'm the co-founder of Design Gurus. I'm also the writer of the Grokking series. You might have heard the online courses Grokking the System Design Interview and Grokking the Coding Interview. Today we are going to discuss this small presentation that I have. Mostly, I would actually like to see if you guys have any question related to problem solving in general, or coding interviews or system design interviews. I have some experience giving interviews and taking interviews, and also like writing about them too. So this presentation is all about how to efficiently use this online website, which is one of the famous for the coding interviews. It's called LeetCode. So today we're going to discuss what would be an efficient and smart way to use that website, and actually how to smartly prepare for coding interviews in general. The topic says don't just lead code, follow the coding patterns instead. We will discuss a little bit about the coding patterns that I'm trying to talk about here, and what's the smart thing about them. So this is the agenda of the presentation. We'll start a little bit about the motivation, which I discussed a little bit, that what is the most efficient way and smart thing to do when you're preparing for a platform like LeetCode, because there are a huge set of coding problems available everywhere. There are multiple websites, multiple platforms that help you prepare for coding interviews. LeetCode has around like 2,500 coding problems, And when someone is trying to prepare for coding interviews, it looks like a daunting task. There's so many problems and so many things to do. So it's really difficult what to focus on, and how can you optimize your preparation time or reviewing time, how different techniques you can review, so that you eventually, I mean, the target is you want to be successful in the interviews and in general problem solving. We will actually go through the three important, I say, topics under coding interviews related to coding problems. One would be the data structures. You guys might have heard. I assume everyone is from computer software or IT background, and they understand the data structures, like hash table or tree stack. We will see what are the important data structures, and similarly different algorithmic techniques, like we have divide and conquer technique, or greedy algorithms, or sorting algorithms. We will just review them a little bit. Also, the third thing would be the coding patterns or algorithm patterns, you can call them. For example, you might have heard the 2 pointers approach, or the sliding window approach, or the depth first, breadth first approach. So these are all algorithm patterns, as I say that. We can have a question answer session in the end. Or if anyone has any question, they can ask me anytime. Actually, I'm fine too. So let's see. Is the slide visible properly? People can read this thing, or is it too small? I can actually maximize the screen too.
Enlarge the slide.
Please say it again.
Enlarge the slide. Make it big.
And make it big. Yeah. Thanks for. How about now?
Yeah, it's fine now.
Okay. Thank you. Thanks a lot. All right. So as I said before, LeetCode is probably the biggest coding platform out there. It has around 2,500 coding problems. So this graph over here shows the problem distribution. Each problem in coding at LeetCode is actually tagged with different terms, you can say. Either it can be an algorithm, or a data structure, or a coding pattern, as I call them. So this is the distribution. For example, we can say the biggest number of problems are related to arrays. They're like 1,142. This means that there are around 1,142 problems that are tagged with the term array. So those problems are somehow linked with arrays. Similarly, the second number of the most frequent tag appearing in LeetCode is a string. Then there are 549 problems, and then we have all the things. These are around 40 top tags. I have tried to put in a graph here. There are some tags, or some techniques, or some data structure that are less frequently used. They're not here, but around most famous ones, these are around 40 those topics that someone can actually revise or prepare to learn problem solving or coding interviews. So we will actually try to figure out some important data from this one graph, which can actually lead us towards this efficient strategy that I believe everyone should follow. Okay, so the same graph, but here we have listed what are the top data structure with with the highest return of investment. Like if you really want to invest your time on some data structures, what could be those data structures based on the number of problems lead code has. So these are top 8-10 data structures. So if we ignore the first two, the array and string, those are, you can assume they are very basic data structures everyone know, and a lot of problems they are tagged with array or string, because mostly every algorithm they take input or output either in an array or the string. So every problem somehow linked with an array and string. So it's not like something which is a very difficult algorithm, or it's a very basic fundamental. These two data structures, array and strings, they are very fundamental. After that, the most important 5 data structures would be, one would be the hash table, or hash map, you can say. Everyone must have some idea about hash tables. Then we have tree. It could be a binary tree or binary search tree, or even k array trees or ternary trees. There are many trees over here. Matrix is precisely an array, but it's a 2-dimensional array. Stack, we already know. Heap or the priority queue is the next data structure. Then we have less frequently used, like graph, linked list, try, and a queue. But the most important look like are the hash table, tree, and the matrix. They have quite big number of problems linked with them. So if we try to focus on these like 3-4 top data structures, you'll be able to solve a lot of problems with them. Yeah, so this is just a review about the data structures, how the data structures are playing in the problem domain, in the lead code, the word. The next thing would be the algorithmic techniques, the same graph, and we want you to see what are the top algorithm techniques with the highest return on investment. So if you see, the top one is the sorting techniques. There are so many sorting techniques available. The 5-6 top, like the quick sort and the merge sort are the famous techniques that are used quite frequently in many problems. They're variations or some part of the sorting as well. The second most important algorithmic technique would be the greedy algorithms. Then we have this binary search. It's a searching algorithm. You guys might have heard it. It's a very basic searching algorithm. This algorithm is used a lot. There are a lot of variations of this algorithm. But the basic one is so fundamental and rudimentary, and that everyone should understand this. Backtracking algorithms used with the recursion and divide and conquer, they are also very important. Yep. Okay, the third thing I mentioned in the beginning was the algorithm patterns, or the coding patterns, you call them. These are some of the top coding patterns I have listed over here. The depth first search and the breadth first search are the most frequently occurring coding patterns among all the problems. Then comes the binary search, the 2-pointer sliding window, monotonic stack is another interesting data structure related to stacks. Union find, memoization is related to dynamic programming. It's one of the dynamic programming technique. Topological sort has 28 problems tagged to it. It's a very important. It's not very, like, there are not so many problems, but it's a very interesting algorithm pattern, and a lot of problems actually do appear in interviews. Yeah. So in these last three slides, we have reviewed what are different important data structures, and then algorithm techniques, and then the algorithm patterns. So the goal was, or to conclude actually from all that data, is like, what should one focus on, so that you have overall highest return on your own time investment, time and energy investment, and what techniques you should learn or revise before your coding interviews. So these are my suggestions. So these are the top 7 techniques overall, or the coding patterns you can call them. You should focus on these 7 that will help you solve like hundreds of problems. So these you should have very good basic understanding about these 7 topics. Of course, I mean, you can, I mean, it's just a recommendation. It's not like guaranteed that the questions will come around these techniques, but these will give you the highest return on investment. The top one is 2 pointers technique. If you guys have already know about it, it's a very simple technique. You use actually 2 pointers to traverse an array or a list kind of thing, and solve your problem using 2 pointers. Generally, those 2 pointers can move. One pointer starts from the beginning of an array, and one at the end, and then they move in the opposite direction to solve the actual coding problem. There's so many problems linked with this technique. All the arrays and string, most of the arrays and string problems can be actually solved somehow with 2 pointers. There's also a technique called fast and slow pointer. Again, it's a 2 pointer variation, but the technique actually tells us that we move the 2 pointers in with different speed. One pointer moves with faster and the other slower. Like one pointer could be moving 2 steps every time, and one pointer could be moving just 1 step at a time. So 2 pointer is a very important technique, probably the most important, and its variation fast and slow pointer, especially fast and slow pointer, is used in linked list a lot. The second number most important algorithm technique would be the sliding window. Again, it's related to arrays and string, and it is used in most of, it utilizes the data structure hash table, and as we saw earlier, that hash table is probably the most important data structure one should focus on. Sliding window is a very very handy technique. You declare a window in an array, and you move the whole window a step in every step to calculate something or to solve the coding problem. Then, as we saw, the depth first and the breadth first algorithm, they are the most frequently used algorithms, algorithm techniques, and the coding pattern. So the third and fourth in my recommendation is actually these 2 techniques related to. There's so many problems, trees and graphs, and matrix could be is like a graph as well, right? In matrix is a 2-dimensional array, and each cell of that 2-dimensional array could be a node, and they have linked with other neighboring nodes. So it can be represented as a graph. So matrix or the tree or the graph, they can all be traversed, and like all the problems related to trees and graphs can be solved using the depth first and the breadth first. So that is our third and fourth most important algorithm technique. The fifth, as I told, the binary search. Again, it's tagged with the arrays problem, and we saw so many arrays problems are there. Binary search is very basic algorithm, but they are very interesting variation of this algorithm that helps you solve coding problems. In the course, Grokking the Coding Interview that I wrote, I actually introduced this pattern and all the related problems that can be solved through different variation of binary search. The sixth recommendation is interval merge. There are not a lot of problems related to interval merge, but this pattern is very famous, and I mean, I've seen so many interviews where people saw a problem related to intervals. You'll get a list of intervals, and either you're merging them, or you're adding a new interval, or figuring out if the intervals overlap, or they're like bunch of 20-30 problems on lead code related to interval merge. They're not very huge, as I said, in number, but somehow interviewers like them a lot, and they appear a lot many times in interviews. The seventh is related to recursion and backtracking. It's a very interesting techniques, overall backtracking. You use recursion, or even depth first kind of a way. We use depth first as well, using to actually implement backtracking. So learn about recursion and backtracking. It helps you solve like dozens of problems. Yeah. So that is actually overall my presentation. If you guys have any question, I'll be happy to answer related to this presentation, or in general about coding interviews, or like system design interviews, as I said in earlier. Yeah. I mean, if you guys have any question related to, for example, these techniques, these recommendation, I can answer that, or anything academically.
I have
If
some
you
questions. Okay. The first question, that was sent to me, is for problem solving. Is the hacker rank is better, or is the lead code?
okay, yeah. I would say lead code is a little better. These are very famous platform, both HackerRank, and there are even a couple of more. HackerRank, lead code has a big community around it. Everyone go there, and it has a very interesting discussion tab where people actually uh, discuss the solution they have written about a coding problem, or the challenges they are having. I think it has the biggest community over there, and you learn a lot from other people. So I would definitely recommend lead code. Platform wise, I think they both are very good. They both provide a huge set of problems and help you um, you know understand problem solving and coding problems. Yeah. Lead code also has, I'm not sure HackerRank has it, but lead code definitely has this tagging feature where they tell you what companies ask what type of questions. This helps you to prepare those questions. If you are preparing, if you are targeting a certain company, you can search their problems and get a feeling, get an understanding of what type of problem they are asking, and then focus on those problems. That helps a lot. Yeah.
Okay. Someone asked me, is it suitable if we use C++ is better or Java or any other language? Which for coding interview we use a language suitable language.
Yeah. I mean, you should use the language that you are most comfortable with. Um, um, First of all, I think that would be the recommendation. I personally don't recommend C++, but I have given my initial interviews in C++, because academically that was the only language I actually learned in my university days. Um, uh, like efficiency wise, I would say Python works great. That is probably the most easiest language to learn. And I mean, not I mean, I would say easiest language to learn, but that helps you a lot with solving coding questions easily, especially in an interview setting. um, mm, like if you imagine, you might need like 20 lines of code in C++ that can be solved like in 10 or less lines in Python. So that's why I would recommend, if you know C++ and Python, try going with Python. But I would not learn a brand new language just for interviews. Um, uh, I mean, you can learn a language anyway, to really practice learning a new language, and then if you are good at it, then you can try. But otherwise, I think you should go with whatever the language you are most comfortable with, because it is very, you know. Very negative, big negative signal that if you end up not knowing certain aspect of the language, or you don't know how to work with the data structure in a particular language. For example, if you end up using a heap, and you don't have much understanding how the heap works in, let's say, C++ or Java, then that's very big negative signal. So better to practice your data structure, everything in the most language, the most comfortable language, and then focus on that. All right, I guess, I mean, uh, if you like, if anyone has a question, they can. Yeah, someone read.
I have a question.
Yeah, go.
For me, I'm not a CS student. So what is the amount of data structure or algorithms should I learn to just working an interview? Like, I'm not an expert in algorithms and data structures, so I want just to pass an interview. So what should I learn?
Yeah. The basic things that I mentioned, for example, the data structure algorithms, those slides mention what are the, for example, uh, these are the top data structures. So data structure is the most important thing I would say you have to learn. Get your data structures. Uh, you know, you should like work on these data structure first. If you have a very solid understanding of these, then most of these things related to coding problems on interviews, they become easy to understand. I mean, you still have to learn them and practice a lot of questions, but data structure is probably the most important thing. um, uh, how much or how many, it all depends, I guess, where you're applying or what is your target goal. Of course, as a computer science graduate person, you know most about these data structures. But if you're not coming from a computer science background, you should actually properly invest on learning these things. Either you are going through a boot camp, or if you are having a diploma or a degree around it. So focus on data structures. Learn, for example, the ones that are mentioned over here. I would still go array string, hash table, tree or binary tree, a matrix, stack, and a heap. Graph could be an advanced data structure, but linked list and queue could be the basic ones. So I think 7 8 basic data structures, you should definitely work on it. You should have a full understanding about these data structures. And then of course these algorithmic techniques, especially the sorting and the searching technique. In searching, we are just referred binary search, but sorting techniques, as I mentioned before, the quick sort and the merge sort, they are the most frequently used sorting techniques. The variation of them too. Um, there are other sorting techniques, but they are less frequently used. So I would say those 7 8 data structures and these couple of techniques, sorting and binary search, and you can call it, I mean, and recursion, you can say, these three algorithm technique would help you solve so many coding problems and clear the coding interviews. Yeah, that's the minimum requirement, I guess. Yeah.
Okay, thank you. I have another question, if you don't mind.
Yeah. Go ahead.
Um, okay, I have read the Gorking Algorithms book.
Okay.
It was a little bit easy because it uses Python language.
Mhm.
I understood the concepts very well, but I think when I've tried to solve the same problems with Java, for example, the code becomes much bigger,
Mhm.
and I think I couldn't be able to solve the same problem with Java, but
Mhm.
I understand the concept very well.
Mhm.
So should I study data structure or algorithms with another language than Python, just to be familiar with the fundamentals like pointers and how to connect it to arrays together and all of that, or Python is fine?
So yeah, so why do you want to do those problems in Java? Are you like, are you going to try the coding question in the interview in Java or Python?
Um, for me, it was just I'm trying to solve it with Java
Hmm.
because it seems to be much harder. So uh, will I be asked to do it to solve a problem with a specific language, or I will choose the language that I will solve the problem with?
Yeah. So mostly they let you choose your language. Like, I mean, they cannot really ask you to write a code in a specific language unless, I mean, you mention that language somehow in your resume or in your interview. So I would say, like, if you are comfortable with Python, then Python is fine. Keep practicing and solving and give your interview in Python. If you are comfortable with Java, then of course you should learn all the data structures, how they are implemented in Java, and all these algorithm techniques. You should be, as I said before, you should be very very comfortable with the basics of that language. How different data structures are implemented. I guess the most important thing is you implement all these data structure, the important ones, in the language that you're gonna try the coding questions. So you should implement hash table, a binary search tree, a matrix, and a stack and queue, a heap. Implement all these data structure in your language, so that you understand how these data structure work, and what different constructs or the functions or different things the language that you are comfortable with, they provide, how what different constructs they provide around these data structure, right? What are different functions of each data structure. For example, in stack, you have this push function that pushes an element on the stack, or similarly you can call another function called peak, which gives you the topmost element of the stack, stuff like that. So you should know the name of the function and how it is used on that data structure. That is the most important requirement, I would say. Yeah.
So thank you. Is there any other resources I should start data structure algorithms from, or should I go online to search for?
So so there are very like people have already written very good online courses on data structure. They are all free as well. Programmers is a website that has it. Even Scalar Academy, they have a very good data structure course. There are very good books too. In my college days, I learned everything from these couple of books. One was, I forgot the name, but it was an Indian author. The name of the book I forgot, but the name of the author was Sartaj Sani. I still remember. I learned a lot about trees and graphs about it, from that book. So I think if you can search about that book, that would be great. Um, what other? Yeah, we used that algorithm book, Fundamental of Algorithm, I guess, or the MIT Press book. The three guys, the Coreman, the CLR book, we call them. It's a very big book. It's you can actually learn all your algorithm or these things. But I guess the most easiest would be these online websites, courses. They are very handy and written in very easy language, so you can practice them. Even in our my website, I don't have written any course on data structures, but I'm in the process of writing, because it has been used by a lot of people. So a new course would be there in, like, probably in a couple of months. I would call it grokking data structures for coding interviews. That would be the name. The two courses related to coding interviews I have right now on my website are grokking the coding interview and grokking dynamic programming patterns. So those are, you can say, assume that you have basic knowledge of data structure. They don't explain these data structures. They focus on mostly in the patterns techniques, as I mentioned. But yeah, you can learn from these online websites. Even Lead Code has, I think, a course related to data structures. I have not taken it. I am not recommending it or anything. You can take a look. But yeah, yeah.
Thank you so much.
You're welcome. Yeah.
Session is ended, and we thank Mr. Arslan Ahmed for giving us his amazing information for the data structured algorithms for the problem solving, and we would be happy to host you this time. And thanks everyone for the audience, for each one attended this session, and see you next time. Bye bye.
Bye bye. Thank you. Thanks.